Hi guys. So for today's lesson, we're going to be dealing with some graphs of sine, cos, and tan. Just before we get into the actual graphs, there's a few words I need you guys to be aware of. Okay, so negative angles. So in the past, I'm sure the idea of negative angles, like, it wouldn't make sense because, like, on a protractor, for example, you're always measuring like a positive angle. But in the context of a unit circle, negative angles can make sense. So the idea is that they move clockwise around this circle. So remember that positive angles moved anti-clockwise, and negative angles are going this way, like going in the opposite direction. So here we've got our 30-degree positive angle, because it's moving anti-clockwise from this starting position right here, whereas this is our 0 degrees right there. And the negative angle will be moving this way. So it's pretty much all to do with this point where it ends up. So this point represents the angle theta being negative 30, whereas this point up here is the angle of positive 30. What I need you guys to note is that this point here, which is our negative 30 point or negative 30 angle, that would also be the same as the positive 330 degree angle. It'd end up at this same point. That's 330 degrees. So I need you to be aware that negative 30 degrees is equivalent to positive 330 degrees because they just end up at this point right here. So just, take that sort of one on board. There's lots of examples like this, like, for example, negative 90 degrees, which would be down here. That would be the same as positive 270. So it's like pretty much just going like in the opposite directions of the circle to make equivalent angles. These angles look different in their number, but they are equivalent. They pretty much work the same way in this context. Okay, also angles that are greater than 360 degrees. So again, that wouldn't have made sense in a like real life sort of context. Like a 360 degrees is the maximum angle. Like that's pretty much completing the full circle. However, in this unit circle context, we can have angles which are bigger than 360 degrees. So, for example, the angle 400 degrees, that would be, that's a full circle 360 plus an extra 40. So the idea is, because it's positive, we're moving anti-clockwise this way, but we're going to go all the way around for 360 degrees, and then we're going to go an extra 40. So we pretty much end up at this point right here. And that is exactly the same as if we just went 40 in the first place. So I need you guys to understand that an angle of 400 is equivalent to 40 degrees because they both end up at this point right here. So whenever you're dealing with this angle, just think, I can deal with this angle instead. It's a lot easier to understand. Like, you want to try and simplify these awful angles into something that's a lot nicer because they just end up at exactly the same point on the unit circle. Okay, so let's get into these graphs. So when we're considering like negative angles and positive angles of any size, like it can be as big as you want, this we can use this unit circle to help us out with the graphs of sine, cos, and tan. Now you've got to remember so to make this simple for us, we're going to be only dealing with 0, 90, 180, and 270. I also want you to notice that if we're going clockwise, this would be negative 90 down here. This would be negative 180 over here. This would be negative 270. And this would be negative 360. And that's also the same as positive 360 for that matter. So let's use these to really help us out with our graphs. Okay, so and also you've got to remember these formulas. Yeah, these are very important, these formulas right here. So let's think that when we're graphing sine, it's all about the y coordinate. So here's our y coordinates right here, this one, this one, this one. It's always the second number of our coordinates because it goes x is there and y is there. And you got to remember that cos You got to remember that that cos of theta is equal to the x coordinate, and then the tan of theta is equal to the y coordinate over the x coordinate. So these formulas are going to be used to figure out our numbers for our graphs. Okay, let's do sine theta first. So at zero, it's the y coordinate for sine theta. And what's our y coordinate at the 0 degree mark? Well, it's going to be this 0 right here. So at 0 degrees, it's going to be 0 for sine. And then next up, we've got 90 degrees. So at 90 degrees, the y value is this 1 right here. So it goes up to the 1. I'm using these green lines here to kind of help us out, line it up properly. 180 degrees, the y value is 0. This is 0 right here. So it goes back down to 0. 270, it's this minus 1. So it goes down here. And 360, well, that's the same as 0, and it was this 0 here. So it's going to be 0 again for 360. Okay, so it goes up here. So with these dots, I want you to make a nice curvy shape. And this is how the graph looks. So we're lining up these dots, and then it continues on afterwards. So that will go on forever in that sort of pattern. And then over here for the negative 90, let's have a look. The y coordinate is negative 1. So it's down here. Negative 180, the y coordinate is this 0. That's here. Negative 270, the y coordinate is 1. And then we just keep this pattern going. So you can see that it's a nice sort of wavy sort of shape. So, sorry, I'm just trying to get this curve nice. So it looks something like that. So try to get a nice smooth curve when you're doing this in your book. So that's sine theta done. I want you to notice that the maximum value for the function is 1. Like, it doesn't get any bigger than this 1. So therefore the range, as high as it goes, is 1. And for the domain, for the bottom, the lowest it goes is minus 1. So it's always between minus 1 and 1. So that's our range right there between those two numbers. And our domain is literally all of theta. Any theta you can put in and get a value. So it's literally everything. So therefore our domain is all theta. We're not dealing with x, we're dealing with thetas. So I can put a theta there for my theta axis. Okay, next up, we've got cos of theta. So how do we graph this one? Now remember, cos of theta was always the x coordinates. So let's look at our x coordinates for all these points. So it's always the first number from now on. Okay, so at 0, well, for the 0, it is this 1 here. So at 0 degrees, it goes up to the 1, so it's up here. Okay, at 90 degrees, it was this 0 right here, so it's down here at 0. For 180, it's going to be minus 1 now. 270, it's going to be this 0 here. And 360, well, that's the same as 0, so it's going to be this 1 here. So it goes up to 1. Okay, now let's do the nice smooth curve. So it's the same sort of looking graph. It's a nice wave. It's just in a kind of a different position to this one up here. And that will continue on in that fashion. Over here, I'm sure you can guess, it's can keep the same pattern. So it's pretty much following the same sort of thing. Okay. And then we get this sort of pattern happening. So it's the same sort of looking graph. I want you to notice, look at what are the differences between this graph and this graph. Well, sine theta goes through the origin, but this one in the middle, it goes through at 1. That's probably the main thing. And then from there, you can kind of remember this sort of look for these graphs. So sine goes through origin, cos goes through 1. That's probably the key thing to remember. Okay, and lastly, tan theta. This is the tricky one. So how do we graph this tan theta? So hang on, I'll just put it in on my charger. So with the tan theta curve, we've got to remember the way to get our values for tan theta is to remember this formula here. So it's the y coordinate divided by the x coordinate. So you've got to look at both coordinates and do division between them, where you're doing y divided by x. So second divided by the first part. Okay, so I'll just get rid of those. Okay, so let's give it a shot. So at 0. So 0, have a look at our coordinate at 0. So it's y divided by x. 0 divided by 1 is 0. Let's go to 90 now. So 90. So look at this point for 90 degrees. Y divided by x. Well, you can't divide by 0. So that is going to be undefined. That's going to give you an error in your calculator. 1 divided by 0 is definitely error. So for 90, we don't want anything. What we do is we literally make an asymptote. We can't have anything for that value. Let's do 180 next. 180, so y divided by x, well 0 divided by minus 1 is 0. And next up, 270, so it's going to be y divided by 0. You can't divide by 0, so therefore it's going to be error or an asymptote. And then 360, well that's the same as 0 here, so it's going to be also on the line. And you pretty much get this pattern happening. So this key pattern continues on for the negatives. So I've got, sorry, that shouldn't be an asymptote, that should be a dot. Then you got asymptote, and you got dots. So it's like dot, asymptote, and that continues on. Now we still need to figure out what our line is doing in these parts between our asymptotes. Now this is the tricky part. I need you guys to remember this sort of pattern for tan. I tried to do this before from scratch, but I really struggled. So here it is. This is what it looks like. The key point is to remember that I've put purple dots for where the graph lines up with the positive and negative ones. So see with the green lines line up with the positive and negative 1. Now the rule of thumb, I'll just line this up so it's nicer with my grid. So the rule of thumb is that that if you notice these values of 1, like where it lines up with the y-axis being a 1, it's going to hit it in between 0 and 90. So it's hitting it on the it's hitting it at the 45 degree mark, literally between. And the same thing over here, so it hits it at -1, smack bang in between 90 and 180, so that's going to be, what's that? That's 135, 135. So these are the values where these are the angles where you get like positive and -1. So at 45 and 135 and in between these two, and it continues on. So -45 is going to be equal to -1. And here, these are making all 1s. And then, so if I get rid of all that, and then you'll notice that as it's getting close, as the graph gets really close to 90 degrees, the asymptote skyrockets up, and over here it skyrockets down, and this pattern just continues each time. So it's continuing like these wavy, sort of snaky sort of lines. So you need to kind of remember this shape. If I put it into a graphing calculator, which does these graphs perfectly, you can really see the snaking sort of shape. You can see here's the asymptote on -90. Here's the asymptote on 90. And it's getting really close to these asymptotes, but it will never touch. It'll just get super close, but never quite get there. And it'll just skyrocket up to infinity. So hopefully this video helps you out with graphing these functions. Good luck with the questions. Bye.